Demystifying Big Data. My name is David Worboys. I'm a solution consultant at QlikTech. I'm really pleased that in the room with me today I have McNeil from Google and Axel Goris from PA Consulting. Both of those are looking to share their sort of insights and knowledge in this space during the course of this session. You'll all be aware there's a lot of noise and activity around the big data space, and has been for some time now, and that's created a lot of confusion and sort of hype, if you like, around what big data is and what it can deliver to people, and how indeed you might go about implementing that. So the session today is to try and push through some of that confusion and identify what sort of things are available and how you might, in reality, work with that in terms of delivering a big data solution, or indeed, if you already have a big data solution, how you might extend access to that through your business user community. To help us with that, we have an agenda in place which is broken down really into these 5 sections. The first one is a very quick introduction to big data, some of the characteristics around big data. Then I'm going to ask McNeil to describe the work that Google's doing in this space. Matt will take you through a sort of a historical timeline introducing the development of big data and explain what Google are currently doing in this space. Then we'll look at how we can extend that access to a wider business user community. And then Axel from PA Consulting will step in and give us his thoughts and views on issues around big data delivery, including a demonstration of QlikView sitting on top of Google's BigQuery. Then we'll have a summary section and finish up with a question and answer session at the end. So jumping straight in, the first question I'm always asked whenever we get to a session and start to talk about big data, everybody instantly comes back with, yeah, but how big is big data? As if there's some sort of cut-off point where anything above a certain value is big data and anything below that is not deemed to be big data. And there's a lot of measurement terms like terabytes, exabytes, zettabytes, yottabytes to describe various sort of levels of data volume that you might be trying to handle. In reality, that's kind of the wrong way to perceive it. If you have too much data that can currently be handled by the environment that you're using, then you need to start looking at alternative strategies for handling that data in an efficient manner. And one of those strategies may be to move to a big data solution. So rather than looking at volumes of data, you can start to look at the characteristics of the data that you're trying to work with. And you'll hear people a lot in the big data space talking about the 3 V's. And those 3 V's are volume, variety, and velocity. We're all aware that there's a lot of large volume of data available these days, and within organizations that's growing dramatically. People are making a lot of speculative claims about how much that data is going to grow, and people like IDC, as you can see on the screen, are suggesting something like 8 billion terabytes of data in the world by 2015, and there's a number of views of how much data will be in evidence. The second one there is probably more interesting, which is the variety, and we start to see structured, unstructured, and semi-structured data. Structured data is typically the sort of information organizations have worked with for many years. It's the transactional processing systems within your organization that are working on data and making that available. The unstructured data is probably the more modern types of data. So really we're looking at web type data, things like blogs, forums, Twitter accounts, and so on. And a lot of that tends to be around things like sentiment analysis. So although we're delivering a service or a product, how are our customers or the community perceiving those services and products? And it may be hard to get that directly from the customer, but by monitoring blogs and forums and Twitters and so on, we can actually get access to that data. The semi-structured piece is more around machine-type generated data. So semi-structured tends to be things like log files coming out of devices on a network, and then we'll have some structure around date and timestamps, maybe the source of that information, but there's usually a textual element in there as well describing what the event was that was triggered. The third one of those V's, velocity, we're all conscious again that there's a large volume of data and that's growing dramatically year on year. And I think that the most comments I saw was that something like 90% of the data that's available in the world today has been generated in the last 2 years. And it's certainly showing no signs of slowing down. And I think that's particularly true around the unstructured and semi-structured data, as we're seeing more device-generated data and more people are carrying mobile devices where they're constantly interacting in real time with systems, raising views and comments. So I just wanted to cover off a couple of examples of people doing big data. The first one of these, this is a QlikView customer, King.com. King.com are one of the largest online gaming companies in Europe. They have something like 40 million monthly players, and they're playing something like 3 billion games each month. In total, that's generating somewhere around about 2 billion rows of data each day, and trying to analyze activities within that volume of data has proved very difficult. And so putting QlikView in as the front end has allowed their marketing users to be able to analyze, essentially for the first time, marketing campaigns that they're activating to try and track new customers, what sort of games people are playing, what is successful, what's not successful, and getting a real insight in terms of behavior within that environment. The second example is Virgin Media. Virgin Media, as you'd expect, have a whole series of network infrastructure elements, and those network elements are generating something like 8 million rows of data every hour. And what they're doing is reconciling that data with customer information that they hold and network topology information. And the value that they're getting out of using QlikView in that environment is the ability to quickly identify faults. But rather just identifying faults that have already occurred, being able to start to predict areas of that infrastructure that might well fail, and so being able to proactively respond before it becomes a network issue. So essentially saving time, saving money, and offering a better service to their customers. So that's the value they're getting out of being able to analyze that large volume of data. So at that point, I want to just pass over to Matt, and Matt's going to describe some of the historical timeline elements of big data and what Google are currently doing.
Thanks, David. So I'm Matt McNeil. I work in our Google Enterprise business, and I thought there's two things I'd really like to take you through today. Briefly just say what Google Enterprise is. Google's a big company, and if you look at our mission, which really relates to organizing and managing global information, we have a number of big bets across the company, which range from search, where we started, through to YouTube, obviously Android and mobile space, social, maps, geo services, and most recently I've been involved in our cloud platform strategy. So Google Enterprise fits into that. It's one of the core divisions within Google. We've been around for getting on for 7 or 8 years, and initially we started by actually taking the search technology out into the enterprise marketplace with the search appliance. It's a very mature industry. We have 30 to 40,000 customers on those devices at the moment. But also other areas, if you like, the three of the key units which we've had traditionally. Search has been one, geospatial, maps and Earth has been another, and obviously over the last sort of 4 or 5 years, our Google Apps and collaboration space is really been making a big impact in the market. The area I'm working on is a fourth area which is new. Within the last year, we've launched something that we call the Google Cloud Platform. And the essence of this is to make available not so much the products that Google provides to an enterprise user, but the infrastructure and the capabilities upon which we build our products. So if you take something like the Google search, where we started back in 1998, it's often renowned, I suppose, as one of the most simple pages on the web. And if you remember back in the late 90s, there were people like InfoSeek and AltaVista who were actually some of the first people into the search market. The trend really was towards complexity and creating a portal experience. And one of the things that differentiated Google at the time was actually just to focus on one simple thing. But although it's a simple looking page, actually to make it work is very, very challenging when you're having to deal with search volumes at the volumes that we deal with of data. How do you index the web and return results from the complete web copy in our indexes in under 250 milliseconds? And in order to do that, we've had to radically rethink some of the assumptions that we've made about technology within the technology industry for the last 20 or 30 years. Our infrastructure is run by a guy called Urs Hertzler. He's staff number 8 within Google. And originally he came from a leading position in the academic world. And over the years that we've been building, he's been very keen to maintain the academic integrity. So he has led by publishing papers of Google's research into some of the work that we've been doing. And some of those are very important within the big data space. We published a paper in 2003 and 2004 on 2 technologies called the Google File System and something called MapReduce. And these were the seminal papers which led Doug Cutting to go and create the Hadoop product, which is now sort of really seeing its day in the sun as big data has really taken hold across industries. And we're very, very pleased to see that technology get out there into the markets and available. Other things which you may not know about, things like the Big Table paper that was produced in 2006 gave rise to the NoSQL movement, which has provided really the basis today of massive, large, scalable web applications that we take for granted. And that technology really, those concepts are what really allowed that to happen. More recently, we've continued publishing papers, and there's a couple that I probably want to pull out. There's one called Dremel, which documents our internal business intelligence systems, and it's something I want to talk a little bit more about today, as it sits, I think, at the core of some of our big data capabilities. And actually Colossus, which is actually a replacement for the Google File System paper that we published back in 2003. Now, with both of these, we've taken a slightly different approach. I think we learned a lot from being involved in the Hadoop development, but we felt that we actually had these technologies running in our data centers prior to 2003, and really we can make these technologies available much more quickly to the markets than the sort of 10 years of redevelopment that were done by the great work that's done by the Hadoop guys. So with regard to Dremel and Colossus, what we're actually doing is externalizing these technologies directly as products for people to just use, so that other people can just simply use our systems. So Dremel, for example, has been externalized as Google BigQuery. Colossus is available to you today as Google Cloud Storage. Now what's interesting is some of these newer technologies actually have been moving forward the research over the last 10 years. And a great example is actually, if we go back to that MapReduce paper, there are 3 key examples which we quote where we were using the MapReduce technologies within Google. One was generating our search indexes, which today are about 100 petabytes, probably more than that since this number was taken about sort of 2-3 years ago now. But at the time we were having some issues, and the reason for this was it was taking about 5 days for us to generate our web indexes as the web was exponentially increasing in volume. And our board turned around and said, that's not good enough. If someone puts a page on the web, I want to see it in the indexes within an hour. So they actually developed a completely new approach to that and brought it down to 30 minutes. So on average today, you publish a new web page, it should be in the Google indexes within 30 minutes anywhere on the web. Similarly, when it comes to things like graph analysis of social structures or network structures, topologies, or mapping and routing, you can use MapReduce to be doing those sort of pieces of work, but actually it's not effective. There are more effective ways of doing that, and if that's an area of interest, there's a very interesting research paper we published in 2010 on a system we call Pragle internally, which has some fascinating concepts. And I think finally one of the most important ones is Dremel, which I mentioned earlier. And what Dremel is allows us to query 100 billion or a trillion row data set in under 10 to 15 seconds interactively. So, if you think about some of the log files we might be getting in the paper, I think we quote telemetry streams off our hard disk fleet, for example. This is really critical information to our business, but so is understanding how our search is indexed and understanding how our customers are engaging with Google as a whole. All of these go into Dremel, and we use this internally to be able to drive incremental value and understand what's happening within our systems and our users' communities. So the thing that stands out about all of these and why we developed them is we were looking for performance increases, and they offer about a sort of 2 orders of magnitude performance increase over the original MapReduce algorithms that we developed 10 years ago. So what you see in some of these papers is potentially things that could be influencing the industry over the next few years. Which is quite an exciting place to be working at the moment in Google. So I'm just going to take a step back and just finish really with how we're viewing this platform and give you a sense of the way it works, because it is breaking the mold slightly in the way that we consider how development and we manage data full stop. So if you look at Google, every single application we build, whether it's search or it's analytics, it's YouTube, it's Google Apps, it's Maps, everything we do is actually built on one single global platform. And one single global data network and comms network. We're actually, I think, the third largest server manufacturer globally at the moment. We don't sell any of those servers. We're just building them ourselves for our own data centers. And we have the second largest global data network. We've invested very heavily in a global dark fiber network in order to keep these data centers in sync. The way this is built, though, is that the unit of compute within our data centers is not the server. It's the data center itself. So in concept, we can pull a whole data center off the grid in order to upgrade it or maintain it without even the Google file systems knowing or needing to be aware that we've done that. And then we can upgrade it, we can put it back on and simply undrain the data center and resync it back onto the data center network. This gives us a huge amount of flexibility and resilience within our systems. So if you look at where we look at the data storage and distribution layer, that actually would sit above the data centers and across them all. So when you write a file object or an object of data into Google's file system, it actually gets digitally shredded and written across a number of data centers in a number of zones. So that file is always available as and when you need it. The second big area here in this storage area is actually the way we've rethought security. And we've moved away fundamentally from the sort of castle and moat security model where you put up big firewalls and you put all your data inside them and then you hope that that will keep it safe. I think what we've found, especially with things like home working and mobile devices starting to come on the scene, and actually a lot of the times we want to be starting to share data across our supply chain or with partners, we start breaking down this model of the firewall. So we've moved more to an atomic security model where every single atom or unit of data is secured. It has an owner, it has permissions, it has a sharing audit trail. So an example would be something like if you were creating a Google Doc, it has an owner, there are people you share that document with, and you can see how it's being shared over time. And this is a very important thing when we're dealing with data in platforms like this, that we drive security down to that level and make that transparent. Once you've got data in place and distributed across the systems, then is when you can start looking at the data analysis services. So when we talk about Dremel, we talk about Praegle or our translation systems or our machine learning systems, they will all sit in this layer. And by definition, if you look at the data volumes we deal with, they're big data services. And actually this area has been what's been driving our research in this area over the last sort of 10 years that you can go and read about in those research papers. And then finally, and something I'm not going to talk too much about today, we actually build our applications on top of all these services. So if you're an application developer in Google, you don't deal with servers and infrastructure. You can write an application and simply deploy it to the runtime frameworks. It'll work for one person, it'll work for 10 people, it'll work for 10,000 people or 10 million people. And this is very important within Google. You take something like Google+, which we launched in July 2011. In the first 90 days after launch, we got up to 40 million users live, and we did over 100 feature releases in that time. Now, when you're looking at systems running at that scale with that number of users, you simply can't get that velocity if your developers are playing around with infrastructure and servers. So for us, this is a very important concept of really looking at how we provide these very powerful tools and environments as services and actually abstracting away from the infrastructure. So a lot of our customers, and actually people who left Google to go into startups and things like that, started coming back to us a few years ago and saying, actually, we want to continue to use these concepts and these services. So we started a strategy of really looking at each of these areas and how we can externalize and make them available to other people. So on the runtime and application framework, you've got things like App Engine, which some people think is a bit of a quirky Java/Python environment, which in a way it is, but what it really is externalizing the way Google builds applications. So if you want to build an application that can work from 1 user to 1 million users, then you can do that on App Engine. In the data services layer, obviously Dremel is something which I've spoken about. We've externalized that as a product called BigQuery, which we're going to look at an example of today in conjunction with QlikView and the work that PA Consulting has been doing. but also our translation services, our prediction API is another thing that we've put out in there, and that will continue to expand as we work through this. On the storage layer, we've obviously got Google Cloud Storage, we've got Cloud SQL, and about 10 months ago, we also announced at Google I/O last year, Google Compute Engine, which is starting to actually externalize some of the raw infrastructure through virtualization of Google's data centers. So if you're doing big data services like running Hadoop, you can run them in Google's data centers very, very effectively, simply because you're running it on an environment which was built for data processing. And there's some quite interesting benchmarks in that space. So this is Google's platform. And I think, if you look at the data services, you see this reflecting some of the things that Gartner's been talking about, which is actually moving away from a paradigm of batch processing, which is what MapReduce actually is, into something which is far more focused on monitoring and prediction and getting a much more interactive and real-time engagement with the data. So this is what Dremel is providing with us. It allows you to query 1 billion rows of data in 10 seconds. Your interaction with the data is very different than if you're waiting 10 minutes or half an hour for a query to come back to you. So some of the new questions which we're all facing today, around social CRM or customer cohort analysis is a very big one, or even just looking at data bag exploration that comes from these telemetry streams. These sort of systems are allowing us to ask new questions, which I think is exactly what David was saying earlier on. And that's what's exciting about the tools which are coming up, allowing us to work with data in new ways today. So I wanted to talk very briefly about how it changes our interaction with data and the way we go about these processing. Everyone's talking about big data this year. I think some of the big problems are there's a lot of talk, there's not all that much doing. And some of the concerns people face is actually building an infrastructure, for example, like Google's, which allows you to start processing data, can be very expensive in terms of investment and just time. And we don't always know that the results are going to be there that we expect. It's simply because it's a new industry, it's very exciting because of that. So PA Consulting was working with the NHS and actually got a data set of probably 1 billion row data set of 15 years of patient activity, so accident and emergency admissions. And actually, the NHS had a real problem and needed to process this data set quickly, but without having to stand up £1 million worth of infrastructure in order to do so. So PA Consulting took a very agile and incremental approach, and this is, I think, the real interesting thing about what we're starting to see today. So the first thing they did is they just simply took the data and imported it into BigQuery and then used the web UI just to get a first load of the data and a first cut exploration. What's in there? How's the relationship? What can we see with regard to the data and how we might want to slice and dice that? Very quickly from that point, then moved into simply using spreadsheet connectors to import them into things like Google Spreadsheets or Excel, so that you can start working with this data and get basic visualizations out and saying, what are the sort of things we want to be seeing and playing with? And this is happening within probably 2 or 3 days of kicking off the project. And then next stage was actually starting to take it through the data analyst view, looking at it in terms of things like geo-mapping. And then finally, once that sort of evolved, they used the QlikView technology to start pulling these together and presenting them into very powerful management dashboards. And this whole project was taking 1, 2, 3 weeks to get to this sort of stage. Now, that's the sort of thing which is very, very achievable and very incremental and agile. And those points, I think, are absolutely crucial as we explore these new opportunities that big data are bringing to us. Google's always had this sort of idea that, you don't morph ideas, you've got to morph ideas, you don't kill them. To be very incremental, just launch and iterate. You have to be able to afford to fail in order to innovate. And if you can't afford to fail, you can't afford to innovate. And a lot of the way we've built the infrastructure that we're talking about today and the way we're presenting it is there to allow people to try things out at scale without betting the company on it. So, as we go forward, I hope that you get a sense of this sort of agility that's starting to come through bringing QlikView and PA Consulting together with some of these foundational technologies that we've been working on for the last 10 or 15 years.
Thank you very much, Matt. So just taking that on a step, that's given us a fantastic basis for starting to get into the sort of the analysis side of information. And what the big data solution like BigQuery gives us is that very high performance engine for storing, managing and manipulating that data. And by having those very fast query response times, what you can start to do, as Matt was suggesting there, is moving not just through analysis, but also into that kind of monitoring and predictive state. But the next question that's coming out now is, how do I take that from being a tool which is used by a handful of people within an organization who have some specialist skills and knowledge around manipulating large volumes of data, to making that data available to other users within the organization, so spreading that out into the business user community? The two things that really make that possible to do is around adding relevance and adding context to the data. So the big data solution, some people will understand that. There will be some core individuals who are able to make very great use of that. But once we move that into a business user community, typically that business user doesn't have the skills or knowledge to handle that full data set. So what they're looking for is a relevant slice or a relevant slice access into that big data. So if we took somebody like a chief executive of an organization, they may want sort of a very high-level aggregated view across the entire organization versus a product line manager who's trying to get a much more verticalized view, perhaps in a product set, maybe geographically placed, time-placed, but that's relevant to their area of responsibility as a business manager or a business user. The second piece is to add context around that. So we're taking information out of the big data solution and wrapping that and putting it in context with what the organization is doing as a whole. So pulling that data out of operational systems and combining the two things together gives us that relevant portion of data, but in context with what the business is trying to achieve. People who are familiar with QlikView will know that typically QlikView approaches this by batch loading data out of those sources. So it's always been able to go out to multiple data sources, pull out a portion of that data and put it into its own in-memory associative data model to give business users a great discovery platform for being very agile about the way that they manipulate that data in terms of tracking down trends, strengths, weaknesses in the data and coming up with new insights of that data. So as the emergence of the big data sources has grown, there's really been a new requirement that's come to be. And some of these business users are now starting to want to be able to dip into that large set of data that we hold. And so what we need to do is find a way of getting people closer to that pool of data that's held within the big data solution. So in 2012, QlikView released a product called Direct Discovery, which was part of the 11.2 release, which actually allows you to run direct live queries into your big data solution. So the benefit of that is that you can start to take your relevant portion of data that you've loaded into your in-memory associative data model within QlikView, carry on working with that, but as you step outside the bounds of that data model you've got in memory, you can run live queries against your back-end data set. And that back-end data set, as you're running queries, returns the result sets which are displayed within QlikView. And as far as the user is concerned, that's a transparent process. It still fits in with the associative model that they're used to. So if you're familiar with the QlikView's green, white, and gray, that experience actually carries on across the big data set as we're running queries into that data. So stepping back to that diagram again, we were saying that we typically have batch-loaded data from the different data sources. What we're suggesting now is that with direct discovery capability, we can do a hybrid approach where we've perhaps taken a relevant portion of data, put that into memory in our associative data model, given users access to that, but as necessary, QlikView can determine that it needs to run an extra query back into the big data solution to supplement the data that we already see within QlikView. So at this point, what we're going to do is pass on to Axel Goris at PA Consulting, who's actually going to talk you through some of the concepts behind approaching a project in this way. And then we'll actually show a live demonstration of QlikView Direct Discovery in operation.
Thank you, David. My name is Axel Goris. I lead PA's QlikView service. And I'm going to show you today a very exciting demo that we've prepared illustrating QlikView's new Direct Discovery functionality. But before I get to that, I'd like to provide just a little bit of business context. Let's start with having a look at how BI brings together data supply and information demand. Traditionally, this has always been a very supply-driven approach where all data is loaded and cleaned up, structured, loaded into industrialized structures before business users were able to get any visibility of that data. And that approach worked really well for the past decades, and for long it was the only way of doing it, because it was quite a technical job. So this kind of approach offers high levels of control, maintainability, but it comes at the expense of agility. And what we're seeing now is that the world of data is changing, and we're going to have to establish new best practice. So let's have a look at that. What are the new world challenges? Well, first of all, as David already pointed out, the levels of available data are rising exponentially, and they come in through these, higher volume, higher variety, so different structures, maybe unstructured data, and higher velocity. So they're coming in thicker and faster. That's on the supply side. On the demand side, driven by fierce competition and tough economic times, you've got business users wanting to ask different questions more quickly. And they know that there's a lot of value in the available data, but they find it difficult to articulate specific questions for the BI team to build an answer for before they've had a chance to explore and play with the data. So I believe that those organizations best able to discover the value from the available data will be the ones that gain competitive advantage. Thirdly, so users will want to do stuff themselves. So driven by huge advances in IT, user interface design, things like the revolutionary user interface of the iPhone, technology being available in supermarkets, allowing people not to queue but check out themselves or check in the airport themselves. So when people get used to that, why would they then accept having to queue and wait for answers they need to do their work? So just to summarize, traditional supply-driven BI is increasingly under pressure for three reasons. There's more data, users want more answers and answered quicker, and they will want to do it themselves. So let's have a look how you make this work, both from a demand perspective and a supplier perspective. So if you look at this very simple model, and you consider two things that organizations want to achieve with business intelligence. So first of all, from the demand side, organizations want to deliver business value from their available data assets. And they want to do it in a cost-effective and a controlled, maintainable manner, which is more the concern from the supply side. So if you look at two axes, the traditional approach is very much used to be supply-driven, crossing the boundary of IT acceptance, so implementing all the right controls before you provide any visibility to the business. So the issue with that, or the risk with that, is that there's a lot of time spent on things that will never deliver any business value. And the longer you go down this route, the higher the cost of change. So there's a big risk that you end up doing stuff that is not the right things, that are not the right things for the business. So the cost of failure is quite high. As a response to that, you get business users taking matters into their own hands, and with new tools they can, and they do. So initially, this is a great proposition because business users get quick answers, great value delivered quickly, in terms that they can understand. But in the long run, it's not cost effective and it's not maintainable. So, and because you get a flurry of point solutions, often with contradicting data, and what is the right answer? And handing over all those solutions to IT is not going to happen because IT is never going to accept it. But luckily, there's a new approach, which is that you discover the business value first before you industrialize the solution. So using a low-risk, very agile approach, you allow business users, you provide them with the right tools, business-friendly but cloud-based, so extremely powerful, against a very low investment to explore data and try out things. The cost of failure is very cheap. And once you've found that nugget of wisdom or that bit of value that you know you're going to need day in, day out, that's when you start industrializing it, because you can, and you can now, because you'll have a stable set of requirements. And that's where you industrialize and do it more in the traditional way, and you might even use the more traditional BI tools to deliver it. So what I'm going to show you with the demo is that the tools are here that allow end users to explore very large volumes of data. Just one last thing I would like to say about this approach. I usually compare this to drilling for oil. So how oil companies explore for new oil fields. When they do that, they don't start with building refineries. They start with light equipment to do tests. And if they don't find anything, it's fine. They just move on. So again, cost of failure is very cheap. Only when they find oil, that's when they build the infrastructure. And that's sort of the same principle. I'm going to illustrate that with the demo. What we've done is we've taken a large data set from the NHS, which the Information Centre has published. We've put that on the Google Cloud and linked QlikView onto it using the new direct discovery functionality. This data set is a set of prescription data, so all the drugs prescribed by each GP in the country over a span of 2 years, and includes all the detail for drugs in terms of dosage and monthly amounts. This data set has about over a quarter of billion rows, represents about 20 billion spent in pounds sterling, and represents about 2 billion prescribed units. Now, there's tremendous value in this data set and other data sets alike for the NHS, waiting to be mined, but the sheer volume poses a real challenge. And this is typically dealt with by asking people to define their queries, which are then run overnight. But the downside to that is that when you come back the next day and you get your answer, it might raise 3 new questions, or it might not give you the thing you were looking for. And when that happens, you've just lost a day. So I will show you that the tools are here now that allow end users to have a free-flowing experience to explore large data sets. And as someone in Google called it, having a conversation with your data, which I think is a good metaphor. So just a little bit about direct discovery. So the big data set is not loaded into memory. It sits on the Google Cloud, which means QlikView lets BigQuery do the heavy lifting because that's what it's good at. And it sends queries driven by the selection of the users. I cannot stress the significance of this enough. This is a real game changer. One of the first point is that it requires very little preparation. One of my guys built the demo in a few days, and probably next time he'll do it even quicker. So you get up and running in days. There's no indexing, there's no complicated ETL processes. You just need to get some visibility of the data, and you get that really quickly at very low investment. So the second point is that you get the full associative experience offered by QlikView, which means you can explore relationships with that large data set and your other data. And it also allows you to drill down into the full detail, the lowest level available, because you don't need to do any pre-aggregation. And the third point is that you can do this with light equipment. So it requires very little upfront investment. Our server that the demo runs on is actually quite lightly spec'd. There's one more point before we get to the demo. 2 more points I'd like to make is that I'd like to manage expectations a little bit. So when we switch over to the demo and I start clicking on things, there will be a delay that QlikView works out what queries to fire off to Google, and while Google runs queries and returns the data. Now, this morning I had a conversation with David, who suggested I might sort of warm up the demo by predefining some click paths, which would cause the server to cache the results. But I decided not to do that because I really want to show you the sheer power of this combination and show you that it's not smoke and mirrors. It's actually happening live in front of you, that 300 million rows are being queried and returned as you wait for a few seconds. And keep that in mind while you wait during the demo, because these are game-changing seconds. The other caveat I would like to make is that I'm not a chemist, so we will be talking about different drugs, and I'll explore a few scenarios that someone with domain knowledge might consider. But please don't start quoting me on any of the findings. So let's go over to demo. So let me just refresh this to make sure that the connection is activated. So we've got prescription prescription data. Typical analysis that people might want to do is looking at unit cost for different drugs within a category to look whether certain GPs are prescribing more expensive drugs than others, and whether there's valid reasons for that, or there might be any cost-saving potential. Other analysis parts might be that you look at specific drugs and their outcomes to see whether some drugs have better outcomes, for instance, a lower hospital attendance for patients taking specific drugs. For the purpose of this demo, I'll focus on the first scenario. So what we're looking at here is that we've got the top view showing the total spend by category of drugs. These are the national British classifications as specified in BMF. The blue bar shows you the total spend. So in this case it would be £4 billion for drugs related to central nervous system. And the red bar shows you the number of prescribed units. In the bottom, we've looked at the average unit cost by the total spend for the various organizational units of the commissioning organization in the NHS. So each bowl will represent one of those units. At the highest level, it will be region. That will drill down into clinical commissioning groups, and that will drill down into individual GP practices. The size of the bubble indicates the number of prescribed units. And then, as you do, we've plotted on the map the location of the prescribing GPs. So let's first start with filtering down the years. So as you can see, we've got just under 3 million rows, covering somewhere halfway 2010 to somewhere halfway 2012. Let me start with selecting 2011 because that will provide some numbers that people who are familiar with the data might recognize. And as I've clicked that selection, Google's actually now, QlikView's sending to Google certain queries to return these results. And as you see, within seconds, I've got my results. Now, let's explore the data a bit further. So the classes of drugs with the highest spend are central nervous system, this includes painkillers, and cardiovascular. If you look at the number of prescribed units, cardiovascular is actually the highest. So when you look at unit cost, any change in unit cost, with this, the volume will have the highest impact. So let's zoom into that a little bit. And as you see, it will take a few seconds. It's happening live in front of you. Google's now returning the results now. From here, my colleague, who's an expert in healthcare, suggests that I look at lipid-regulating drugs. Lipids are fats, so these have to do with things like cholesterol. These are the type of drugs that get prescribed. People take.
Sorry to interrupt, Axel. I just had a message that the screen has frozen, so apologies if the screen has frozen. But I understand actually it's now working fine, so apologies for the slight hiccup for those who've experienced it, and we'll continue.
Okay, thank you. Now, apparently within this class, there are a number of different types of drugs, and I've been told that especially the group of statins are interesting to look at. These are drugs prescribed to people with high cholesterol levels. So I'll just filter down my selection, and then from there we'll start to have a look at individual units, the average unit cost as prescribed by different areas in the NHS. So the top two, most prescribed drug is, the most prescribed drug is simvastatin. This is a generic drug. And the next one is atorvastatin, which is a branded drug. And as you can see, by far the highest spend, just under £300 million, is on atorvastatin. So if you look at the average unit cost, which we'll open, Google will calculate for us, then you can see the average unit cost is £25 compared to simvastatin being £1.40. So you can imagine that if these are similar drugs, which they may or may not be, there could be some cost savings potential in here. So it might be worth to drill into that. So let's have a look at the bottom scatter plot. So the north region here has the highest spend, but if you look at the number of prescriptions, it's about 19 million. If you look at Midlands and East, there's almost the same number of prescriptions, but quite a lower average unit cost. So it might be good to understand why, what's the mix of drugs being prescribed here, and it could be interesting to find out whether there's any cost savings potential. As I've selected the north region, it will now drill down into the clinical commissioning groups, and you can see here Liverpool being the one with the highest spend, and also a relatively high average unit cost compared to the loads. There's almost a factor 2 difference. So it might be interesting to understand what's causing that difference. So let's drill further into this. So while we do that, you can see that the number of rows selected is going from 300 million rows down to just a couple of thousand, just to illustrate how powerful this approach is, that it allows you to zoom in from a top-level view quite easily and very quickly. So here you can see the balance between, the ratio between atorvastatin and simvastatin is almost 1 to 2. Now let's compare that with one of the CCGs with a very low average unit cost. So again, Google's working through the answers. And there we go. Here this is about 1 to 5. So it might be interesting for someone in the North region to understand why GPs are preferring atorvastatin over simvastatin in the Liverpool region, while there's a different mix in another region. So I'd like to sort of stop the demo there and just take a moment to consider the impact of this. So I'm just showing you a hypothetical scenario, which is actually close to the truth, but things would be useful to know is that actually the patents for atorvastatin ran out in May last year. So there is now a generic alternative available for atorvastatin that costs about the same as simvastatin. So actually what's happening now is that a lot of GPs are prescribing more atorvastatin. But this is already saving the NHS millions of pounds a year. What I just want to point out is that this kind of exploration approach is now enabled by these kinds of tools and cloud technology. So it allows non-techie people with domain knowledge to explore very large data sets without necessarily knowing where it's going, to form hypotheses that lead to further investigation. And never before has this been possible at this level of low cost and level of ease, and very short startup time, because you get going in days, maybe even less. So what have I shown? I've discussed that the traditional supply-driven approach to BI is increasingly under pressure. We know the issues. There's more data. People want answers more quickly, and they want to do it themselves. I've shown an approach to delivering BI which is more demand-driven, but still offers similar levels of control. And I've shown you that the technology is here to actually achieve this kind of discovery approach. At PA, we believe that this is the new world of BI and the new world of data, and we're already working with a number of our clients to make this their reality. So at this point, I'd like to hand it back over to David.
Okay, thank you very much for that, Axel. That was a fantastic demonstration. What I found really exciting about that is we did have this great conversation earlier about should we pre-cache or not pre-cache some of the queries that we're running. We're chuckling here a bit our side because I think Axel was absolutely right, because what you're seeing there was the power of Google BigQuery at the back end and the capability to return those queries on demand through the QlikView tool. As the system is used, essentially it would warm up, because the QlikView side of things would start to cache some of that data into memory. Now that's not the same in-memory cache as the associative data model. So if you were using a hybrid approach, where you've pulled some relevant data into QlikView, you've contextualized it, you've stored that in your associative in-memory data model, that sits separate to the cache for the data coming out of the big data source. But it does mean that those result sets are all cached. So if somebody's making the same queries against the back end, some of that will already be in memory and you'll get even faster performance on the back end of this. The other bit that I find exciting, this demonstration I think was around about 300 million rows, just short of that. But one of the big advantages of the big data solutions like BigQuery are that volume of data almost becomes irrelevant because it scales up to vast volumes of data with the same levels of performance, and that's what's really driving it behind the scenes. So if we just cut back to the presentation, we've just got a few slides to finish off before we get to our Q&A session. So going the last mile, this is really just a bit of an analogy with the telecommunications infrastructure. Telecommunication companies spend a lot of money installing the whole infrastructure with network devices, routers, trunk lines, cables. There's a lot of infrastructure that's put in place. The central pieces of that are relatively easy to install. So those high-capacity trunk lines are very easy to put in place between point A and point B. And what you're seeing on the left there is actually a schematic of a telecommunication infrastructure. So the brighter straight lines are those high-capacity trunk lines. And what you'll notice is that it fans out to smaller and smaller endpoints. And essentially those are lower capacity, shorter distance links. And at the end point of each of those is either you and me as a house owner getting a service or a business sitting on the far end of that. The issue for the telecommunications companies is that the closer you get to that endpoint, the harder it is to deliver that service and the more expensive it becomes. And so in a lot of cases, either that service won't be delivered because perhaps the population is so sparse it doesn't warrant putting that infrastructure in place, or if they're going to do that, they may well pass on the cost of delivering that service to you. So the analogy really within the big data space is that the big data solutions are fantastic places for managing and processing those data and driving very fast query response times. There's less focus perhaps on how you get that into the business community and into the hands of your business users. So what QlikView is doing on top of that is enabling that mass distribution of data to a wider audience. And that gives you a couple of things really, but one of the benefits is that the business users tend to ask different questions of the data. So whereas you're perhaps, if you call them data scientists, for want of a better term, are analysing the data and finding all sorts of previously unfound insights, your business users are in a very ad hoc self-service mode where they're asking questions about that data on an ongoing basis throughout the day within their area of responsibility to help improve the way the business is running. So people are probably generally fairly familiar with QlikView, but the benefit of QlikView is that ability to bring data into our associative in-memory data model and allow users a business discovery approach, a very dynamic, agile approach to working with that data. The great news about direct discovery is that it sits directly in with that model, and so what it's now allowing to do is extend that same associative experience but down into your big data solution. So combining data that's held in memory within QlikView with data through direct live queries using direct discovery gives you a much richer experience and access to a much larger volume and set of data, but still with the same high performance in terms of responding to those queries for the user. So summing this up, really, there's kind of two sides to this. The first piece is the back-end infrastructure, which is Google BigQuery and other big data solutions sitting out there managing that data and giving us very high performance in terms of responding to queries. And that enables new insights that we've never been able to do, because traditional relational database type technology, once the data volume increases too far, tends to run out of steam, and you cannot run those queries and get the responses back. So it becomes impossible to analyze those larger volumes of data. And putting something like QlikView over the top of that allows you to really approach this in a number of different ways. We suggested there's a hybrid approach. One is to sit on top of something like Google BigQuery and actually do the traditional batch extraction of data into QlikView, in which case we're running purely in our associative data model. The other one is to actually combine those two approaches. Interestingly enough, in Axel's demonstration, he'd kind of gone to a third stage, which was to leave all of the data in Google's BigQuery and use the direct discovery tool to pull information across on demand by those business users. So really there are three levels of approach that you might want to take there. But the important thing is that it gets all of the value of that data from Google BigQuery out into the hands of your business users. And from a QlikView user's perspective, it maintains that QlikView experience, which is all about the associative data model, rapid application development, and the collaboration processes that brings between your user communities. So just before we go into the question and answer session, we just wanted to do a little bit of an advertisement here. That there's an event coming up in June, Big Data Analytics, which Google are actually a sponsor of. So you'll be able to visit the QlikTech stand there on stand 2. We have 2 speaking slots of that event. One is a 15-minute session as part of the main event, and then we have a 45-minute breakout session. So if you're interested in following up on that, then you'll find a lot more information about big data, and Google and PA, I believe, will also be at that event. So we'll be on hand to answer any questions face-to-face. At the bottom of that screen, you'll see our URL. So if you want to go and find out more about that event, whitehallmedia.co.uk/BDA. And if you want more resources in the shorter term, then this final slide here will give you some URLs you could just perhaps note down, which will take you to the QlikTech website, Google's website, and PA Consulting's website, where you'll be able to get more insights, white papers, demonstrations, and so on, to further expand the knowledge that hopefully we've passed over today. So I think at that point, we'd just like to open this up for a Q&A session. So if you have any questions, please feel free to put those in your chat or your Q&A panel, and we will endeavour to work our way through those. Give us a couple of seconds just to get our heads straight around those, and then we'll start answering these questions. First question there is, gents, all looks great, but how easy and quick is it to link this to other data sets?
So this, I'll answer this one. This would be just as easy to link data to any other data set when you use QlikView. As far as QlikView is concerned, it treats the links just as if it would be loaded into memory. So once you know which are the linking fields, then you link those in QlikView.
Yeah, I think it's Matt here from Google. I think this is an area which is very exciting, is actually how you do these sort of large joins. I think just this week we launched BigQuery 1.3 with large join functionality, which we were talking about earlier here. But one of the tests that I saw them running on that was actually joining a multi-terabyte data set to, I think, maybe a 100 gigabyte data set. So you were getting joined result sets in under 60 seconds on that sort of scale of data. Yeah. And of course, all that's, pulls through into the QlikView consoles. Yeah,
and the next question actually links into this. The question is, you're looking at prescription, but it would be very interesting to link this to the HES data that the Google example was looking at. So that definitely, we're finding that very interesting as well, and we've started working on our next demo that will actually do that. And we'll do that either by using the join capabilities in BigQuery, or we might consider a different kind of data model to load everything into QlikView, or using direct discovery.
Okay, I think we'll just step down. So there's a question here from about, is Google BigQuery free for users? Do they need to have QlikView implemented already? I guess there's two sides to that really. I think probably by is Google BigQuery free for users, we're really looking at the capability for the direct discovery piece within QlikView. And so the direct discovery piece is free to users. It's just a standard part of the QlikView product set that was released in 11.2. So if you upgrade to 11.2, you'll find you already have that capability. And so I'm not sure if that answers the question or not.
Yeah, I mean, BigQuery, is a sort of a foundational product. You can go to cloud.google.com and you can actually have a look at it and test it out. It has a free tier, but beyond that, then it's basically priced on a pay-per-use really. So based on the amount of data you process, and that's a very important model, is that it reduces any form of capex at all. So you can start playing with this for a few cents on the dollar really.
There's one here I was just going to pull up. There's a question: why would you use this over the in-memory capability? And the comment is, I regularly use 500 million rows of data, and the response is instant, and the incremental load circa 10 million takes 3 minutes. And I think that's a little bit of approach. Maybe we didn't get that across strongly enough, but with a hybrid approach here, you have the option of deciding what is the best strategy for your own environment. So if you have the infrastructure in place to be able to run those 500 million rows within QlikView and the response times are good, That's fantastic. Nobody's sort of mandating that that data should be in the big data solution. However, if you start extending beyond that volume of data, then obviously there are alternative ways of doing that, and it may be best to leave that data in something like Google BigQuery and take advantage of those very fast response times. But certainly a hybrid approach between those two things is fine, and as you're suggesting there, you're getting very rapid response from that volume of data in your scenario already. Another question here we'll take is, how structured was the NHS data before loading it?
It was reasonably structured. It came in separate CSV files, which we concatenated and loaded up to Google. We then, in the QlikView model itself, loaded the BNF classifications and some information about the conditioning structure, which was fairly straightforward to do. But so yes, it was reasonably structured.
Okay, I think we've asked a few of your questions there. We haven't had a chance to get to all of the questions that came up. So what we're going to do is we have recorded this session, so you'll be sent a link to this recording following the event, and you'll be able to re-watch this session and go through it again. In addition, what we'll do is we'll make a note of the questions that have been raised that we haven't managed to respond to today, and we'll put you a response back to all of those, and we'll distribute those questions out to everybody so you all get a chance to see those. Unfortunately, I think because we're up against, we're just about nearly 11:05 now, I think we've run out of time for today's session. So it just remains to thank you all for attending this event and taking the time out to listen to what we had to say today. Hopefully you've managed to gain some knowledge and some insight into how to build in this sort of environment. And with that, I'll thank you all and we'll stop the webinar. Thank you very much.
Thank you.
Thank you very much.
Thanks a lot.